Okay, I'm going to try and keep this brief. I really do think tomorrow's test is much easier than you think it is. Here's a list of topics that you can expect to see. 4 of them are from the introduction to geometry, and then only 2 topics are going back to probability. 7 questions from here and 3 questions from here. So here's the sort of thing you might see, though I won't give you this table. I expect you to write that on your own. You'll be given some sort of story, and then in that story there'll be some information. For example, you might be able to pull from the story 32% of people like to see stand-up comedy, 53% of people like to read books. As far as I can tell, those 2 things are completely independent. It could be there's some other factor that makes these events not independent, but they seem pretty unrelated, so we're going to treat them like they're independent events. So, in the frequency table, you've got comedy. These are people that like to see stand-up comedy, and people that don't like to see stand-up comedy. People that like to read books, and people that don't like to read books. Since we're looking for the independent, or we're treating them as independent events, we should be able to find the crossover pretty easily. The total is always going to be 100%, so finding these 2 missing spots is just addition. And then to find any of the intersections, you can just use your calculator and multiply, because we are dealing with independent events. So this would be about 32%. And then really from there, the rest of it is probably addition also, to fill in the rest of the chart. But you could use multiplication to find the intersection of likes to see comedy but doesn't like to read books. You could multiply those 2. About 15%. The percentage of people that like to read books but don't like to go see comedy shows is just the product of those 2. And the percentage of people that like both, the product of those 2. And I think it's important to keep in mind that if you were only given this information right here, let's say instead of being given this fact up here, that 53% of people like to read, you were given this fact right here. About 15% of people don't like to read, but they do like to go to comedy shows. Well, you could find out the value of people that don't like to read just by doing division. We know the product of these 2 boxes equals this one, so if we divide this box by this box, we'll get this one. About 47%. So there will definitely be a problem of this sort on the test tomorrow. There will also be a problem where it's more clearly dependent events. And while we're still going to be using multiplication, we aren't finding intersections when we do. So what is the likelihood of picking one boy and one girl? We're going to do that question last. What about 2 boys? Well, that's pretty easy. The probability of picking one boy when there are 5 from a group of 9 would be 5/9. 2 boys in a row would be, well, we just picked 1, so now there's 4 out of 8 remaining, and the multiplication of those 2 probabilities will give you the probability of picking one boy and then another boy, 2 boys in a row. The probability of picking 4 girls in a row is found in a very similar way. There are 9 total students. or people. 4 of them are girls. So the first time you have a 4 in 9 chance of picking one girl, and then one girl is gone. So now there's a 3 out of 8 chance. And then 2 girls are gone. Now there's a 2 out of 7 chance. And now there's only 1 girl left. There's 1 out of 6. So this is a pretty straightforward way to calculate this. And then let's sort of label these so we can keep track. We did questions 2 and 3 first. What about question number 1? What is the likelihood of picking one boy and one girl? Well, the trick here is that there's 2 different ways you could do that. You could pick the boy first or the girl first. So let's say we pick the boy first. That's 5 out of 9. And then the probability of picking a girl is 4 out of the remaining 8. But it could be that we pick the girl first, which would be 4 out of 9 possibilities times 5 out of 8. 4 out of 9 total. And then we pick one girl, so she's out. That leaves 8 total, and 5 of them are boys. So there's a bit of application of your intuition and problem-solving ability that I'm really trying to get you to develop here. And it turns out that these have some equivalencies with the NCR. The probability of picking 2 boys would be, from the total sample space of 9 possible choices, 9 choosing 2, how many different ways can we choose from the boys? Only 2. And from the girls, exactly 0. 4 choose 0 is exactly 1. So this one almost doesn't even matter. There is exactly 1 way to choose 0 of the girls. So this isn't going to influence the calculation. But if you were to check this on a calculator and this on a calculator, you would see that they are the same. And I will go ahead and demonstrate that for you, just in case you don't believe. 5/9 times 4/8. 5/18. Now my claim here is that if we did a fraction and we did 5 choose 2 on top and 9 choose 2 on bottom, we will once again get 5/18. So it's the same. Here it would be very, very much the same. Again, there's 9 that we can choose from total, but 4 of them are girls, or we want to choose 4 total from the 9, and then we only want to choose girls. So of the 4 total girls, how many ways are there to choose all 4 girls? Well, that's only going to be 1 also. So that's our numerator. And then of the 9 total, how many ways can we choose 4 people? And that's our denominator. It's sort of like our sample space. It's the total range of possibilities we want to consider. And if you don't believe that that denominator simplifies down to 1, look at this. 4 times 2 is 8, so those are going to cancel. 9 is really 3 times 3, so that can cancel. 3 times 6 is 18, so this should be 1/18. And if we do this again, but this time we do 4 choose 4 on top and 9 choose 4 on bottom, lo and behold, we do in fact produce 1 and 1/26, which means I multiplied incorrectly because I left out the 7. 3 times 7 is 21. 21 times 6 would be 126. They are in fact the same, even though I mistakenly forgot the 7. So what I encourage you to do if you are struggling with these is to make up your own problem and see if you can get a friend to solve it, and have them make up a problem and see if you can solve the one that they made up, and then talk about what you learned.